All right, so today we're going to start on the transition into the last topic for this course, which is a larger topic, so it's going to continue even after the break here. But it's going to be algorithms for searching and sorting. And the reason that we cover these so heavily is because they are a huge part of computer science. In other words, data processing. And in fact, data is so important that they now have yet another branch of computer science, data science, right? And now we have a major for it. Two fundamental operations for any data processing are going to be searching and sorting, right? They form the basis of pre-processing steps for many other algorithms. For example, if you want to do something more sophisticated, usually the first step is to sort it, right? And then that makes the job of doing that more sophisticated operation much easier. Also, there's a large variety of algorithms and strategies for these two very simple problems. Now, I called them simple, but let's take a step back and let's do a demonstration here, and let's just see how simple they are. So my first question is, when we want to do this demo here, is what do I mean by what I just wrote there? Write a function to search a collection for a particular element, okay? So that's really, really generic. What does that even mean? Well, let's parse it down here. Function, method, whatever, right? To search a collection. What do I mean by a collection? If this were C, what would be our collection? An array, right? If this were Java, is that necessarily the same? No, you also have lists, sets, maps, right? Multi-sets, right? So what do we mean by collection? It's just a bag of things, right? For a particular element, right? So what are these elements? What are we searching? Are they integers, doubles, pixels, students? Yes, right? Any of those things. So you can see that even though I called this simple, even the simple idea here of just, we usually refer to this as searching the haystack for the needle, right? Your search, it's as difficult as finding a needle in a haystack. Here's your haystack. There's a needle in there somewhere. Go searching, right? What are we actually searching here, right? So I want to leave that question for a second, and let's just make a little bit more concrete example. This is something you've done before. In fact, in Hack 7, contains or contains within. So I've got an array here. And I've got what's called a key. That's our needle. This is our haystack, okay? And what I want to do is I want to search through this array to find that little guy right there at the end, 3, okay? So how would you go about doing this? I need a function first, right? So we'll worry about the return type here in a second. What would you call this function? Search, find, okay, oh, wow. Have you been reading the documentation for C? Okay, all right, that's what C called it. We'll get to that later, right? All right, so I'm going to go with something else because I don't want to collide with C's, right? Search, right? In fact, what are we searching for? Well, I kind of hard-coded it here, search for integers. So let's go ahead and call it search int, okay? Because there's another search function that I don't want to collide with either, right? All right, what am I going to take as input, at least as far as C is concerned? The array, okay, so that's a const int star ARR. Why did I make it const? I'm just going to be searching it. I'm not going to be changing it. It's an integer array. What else do I need? The key, okay, int key. Size. If this is C, what else do we need to be passing in? The size of the array. And now it's pretty straightforward, right? It's just an idiomatic for loop for int I equals 0, I is less than n, I plus plus, right? If the ith element, array sub I, is equal to key, then you found what you were looking for. Success, right? Do something, right? Or return something. However, if you get down and you don't find it, what should you return? That means it's a failed search. So return what? Right? Now it's not so easy here. If you were to go back to your hack 7 or whatever you did contains or contains within, right? You returned a Boolean. True, I found what I was looking for. False, I didn't find what I was looking for. And we could do that here too. We could return 1, true. We could return False. We did not find it. Right? But let's think about this a little bit more generally. Okay. What are some other options here for my return type or return value? Not just a simple yes or no question. How could I give more information? Yeah, I found it. And also I found it over there. Yeah, go ahead. Okay, so let's return the index at which we found it. If I find it at the ith index, then I should return I. Okay, success. What about a failure? Should I return false? I did not find it. No, that's an index. That's going to be interpreted as an index. And it means that you found it right here, and you certainly did not find 3 there. So what's another value that I could return here? Could I return null, first of all? No. What's the return type here that implicitly that I did up here already? An int. Okay? So I can't return a pointer when it returns a regular old variable. So I heard it out there before. -1. Why -1? That is definitely not a valid index value in C. Go over to a programming language like Java, or like not Java, but Python, and guess what? That is a valid index. If you've got 5 elements, it's index 0, 1, 2, 3, 4. If you go negative, then it just simply wraps around to the beginning. Right? So you couldn't do that in another language. In other words, what we're doing here is highly language dependent. The statement over here, was this language dependent? Did I mention arrays at all, pointers at all, 0 indexing at all? No. This is a more general problem. And for this, we'll eventually introduce a new concept called pseudocode, fake code. Right? And it's how you describe algorithms in general. But let's go ahead and finish this more concrete example here. Let's make sure it works, first of all. So let's search int index of equals to search. Right? In fact, maybe we should rename this index of, because that's actually what you're getting. Right? But I'll leave that. Array, the size, and key. Right? Now printf found %d at index %d and the line, and I will say key and index of. There we go. There. Let's go ahead and compile this and see if it works. So if this works, where should I find it? At index, it's the last one, so 7. Okay. What if I search for something else? Say 7. I should find that where? At index 0. Right? How many comparisons would I have had to make to find it at the last place that you're looking for? In this case, there are 8 elements, and if you find it at the last position here, 8. Right? But what if you got lucky and you found it at the first place you're looking for? 1 comparison. What if instead I searched for something like 8 itself? Right? What's it going to return now? 2. Why that one? Why not that one? It was right there. Right? Multiplicity. We have non-unique elements. Right? So which one is this actually finding? Finds, or it returns, the first index at which the key is found in the array. Right? The first index, not the last, not all indices, but those are variations that you could have, right? And -1 if no such element matches. Okay, there we go. There's my documentation, right, for why it's behaving like that. Okay, you might want to change it to first index of, or something like that if you want to put it in the name, but documentation is more than enough. So some other the variations of this, right? What if you wanted to find the maximum element? That is still a search criteria. A particular element. Did I say that an element matches a key? No. It could be the largest value, the smallest value, the median value, right? Those are all search problems. What if you wanted to find the all the indices of any value that matched it? Or all the indices of all the medians, right? Those are all very, very common operations, right? But they all have the same exact algorithm. But for each element, if it matches your criteria, success. If none matches your criteria, failure. What would this look like if it were for doubles instead? Let me go ahead and change this to BUR. Right? And let's search this. 0.1, 0.2, 0.8, 0.4, 0.3, 0.5, 0.0, 0.5, and 0.1. And now let's change our key D is equal to, I don't know, 8.5. Let's search for that guy right there. Index of, I'll just repeat that. Search not ints, but doubles. Array, or BUR, N, and key D. Yeah.
You need to change the thing from BUR from int to double.
Okay, thank you. There we go. Do double. There we go. What about this though? Let me do a cut and paste. First hint that this is not something I should be doing. Copy pasta is not a good strategy. But let's do it. Search double. What changes? Double. The types, right? The key and the array type. All right. Does anything else change? Not for this particular example. Let's see if it works. Found it at index 2. Oh, wait, is that right? Oh, I guess I never printed anything. There we go. All right, index of key D. There we go. Oops. Found %f at index whatever. There we go. At index 6 is right there. All right. Okay. That's integers. That's doubles. What if you wanted to search books? Search for a book by, say, a title. Right? What changes now? Book. Right? Maybe I pass in a book, either a key or either an actual book, or hopefully I'm comfortable with pointers, and I do it like that instead. For each book, if it matches the key, then return this index. Otherwise, it's a failed search, -1. So can I use equals equals to determine if the titles are the same? Nope. So what do I need to do here? A string comparison, okay. If strcmp of array sub I dot, why do I use the dot operator at that point? Because it's, array is a pointer. Array sub I is a regular old book. So dot title, and then key. Here I'm going to use the arrow operator. Why? Because it is a pointer title. Right? Now if string comparison returns 0, then they match. Okay? Wonderful. All right, let's continue. Right? Again, this should be a huge red flag here that copy pasta is probably not the way to go. By not title, but by year. Right? I want to find a book that was published in, say, 1999. Right? What do I need now? Well, instead of a book, I could pass in an integer year, something like that. But what if I just passed in a book whose key value had the year set to 1999? That would mean that I can keep it the same. And all I would need to do is, instead of strcmp, is if that's title, that year, I think we had date, published date or something like that, I'm going to simplify it here, is equal to the keys year, then we found a book that was published in that same year. Okay. At this point, I'm going to say, no, I don't want to do this over and over and over and over again. Instead, I want to introduce a new concept that will allow me to write one function to search any type, integers, doubles, books, strings, anything, right? So I only have to write one function, search, right? And then what I do is I give you an array of those elements, but then this other thing over here that says, hey, I've got this book or integer or double, and I've got this book or integer or double. Do they match? Right? We already have that pattern right here. strcmp takes two strings and returns what? something negative, positive, or 0, depending on the relative ordering of those things. We're going to use that same pattern here. Okay? So we don't want to have to write and rewrite the same algorithms over and over and over again. Right? So how do we do this in practice? In general, you do not write your own implementations of searching and sorting. We haven't talked about sorting, but we will after we look at this. Right? Instead, you use built-in functions for doing so. Right? But those built-in functions are generic. They can take an array or list of any type of object, of thing. I won't even use object because that would confuse you with object-oriented programming. Right? And C is not an object-oriented programming language. Right? The problem is it doesn't know what those things are. Right? Or more precisely, how to compare them. Right? You give me 2 books. I don't even know that they're books. How do I know that I'm looking at a title or the year or these are integers now or they're strings now? Right? What I'm going to do is I'm going to pass in another thing. Right? You also need to provide to compare. You provide the function, the search or sort function, with a comparator. Right? So what are comparators? Right? It's not a real word. I don't think if you look it up in the dictionary that it would be spelled like that or whatever. But let's look at a comparator in C. Right? So in C, a comparator is just a function, right, that compares 2 generic elements, A and B. And note here, I'm not using code formatting. I'm using mathematical formatting here. Okay. It returns, as you expect, just like strcmp, it returns something negative if A comes before B. It returns 0 if they match, if A is equal to B, right? Conceptually. It returns something positive if they're out of order, if A comes after B, right? Or B comes before A, however you want to look at it. Okay. In C, a comparator must have the following signature. So it returns an integer. That's familiar because that's what strcmp does. And note here, I'm emphasizing something. It does not necessarily return -1, +1, or 0. It could return -42. It could return +101. Do not read anything into the magnitude of that number, just the sign. Negative, +0. Right? So that's the return value. You can call it whatever you want. CMP is short for compare. Right? This seems new, or it's actually not new, it's just recycled. Well, first of all, it's a pointer, yeah. Also, it's const. We're not going to be able to change it, right? That makes sense. But what is a void pointer? Where have we seen that before? What returns a void pointer? What? No, null is just a very special pointer, but any pointer can point to null. So that is generic in a sense. Right? So when you need to allocate memory, what do you use? Do you use malloc for integers, malloc for doubles, malloc for strings, malloc for books, malloc for? No, what do you use? One malloc to rule them all. What does it return? A generic void pointer that you can treat as a book, you can treat as an integer, or you can treat as a character array, right? So it returns an integer, right, and it takes 2 arguments, right? Both must be const and are unchangeable, or immutable. Both are generic void pointers. Pointers that can point to any data type. Right? Integers, double, book, etc. Right? It can point to anything. Right? Now, why do we do it like this? Well, because it's a generic function. right? If we're going to use this as a component to a generic sorting algorithm or to a generic searching algorithm, then we need to make it generic. And the only way of making something generic in C is by taking away its type entirely, void, okay? All right, so how do we actually write this comparator function, right? Inside a comparator function, you follow the general pattern, right? So one, you cast the two generic pointers as the types of data you expect, right? So if for example, if I'm writing a comparator for integers, then I would cast them as integers. If I were writing a comparator for books, I would cast them as books, right? Now that they're that type, right? Now that they are of a type you can deal with, you compare them, right? You return something positive, negative, or 0, depending on the order you want, right? Then you return that value, and that's it. Those two steps, right? There's not a third step. Yeah, there's not a third step. Okay. So let's, as an exercise, write a comparator for integers, and then go back and write a comparator for books, and then go right back and write some more comparators. See, let's get some practice. So let's come up here to the very top, right? And I'm going to document this. A comparator for integers that orders them in ascending order. In other words, 10 is less than 20. We're going to less than 30, right? We're going to order them in ascending order. Usually we denote this as non-decreasing order, because what if I gave you two 10s, right? They're not ascending, they're not descending, right? So ties is usually the issue, right? But I'll call it ascending because that's a simple enough way of doing it, right? So int compare, int a, int b. Right. So is that a comparator? It's a function, I'll agree with that, and it returns an integer, but is it a comparator? Nope, it must have this signature. If it does not have this signature, it ain't a comparator. And if it ain't a comparator, you can't use it like a comparator. Right? So let's come back over here and change it to const star int, or int star. Const int star. Is that a comparator yet? Nope. Does it match this thing? Nope. Right? Yeah, I made it const. Yeah, I made them into pointers, but they're integer pointers. Right? They have to be void pointers. Void. For that reason, strcmp is not technically a comparator. Right? It can be used as a comparator, but it's technically not a comparator and can't be used directly as a comparator. Right? Okay, so once I'm in here, how do I go about comparing A and B? Right? If I did something like this, if A is less than B, right, return something negative. Right? Well, can I do that? What are these things? According to this, what are they? They're just memory addresses. So if you're comparing that memory address and that memory address, what does it matter that that memory address has a higher number or a lower number? Right? You want to look at the contents. So how do we get the contents of a memory address? Dereference. Except that this operation right here, that only works for numbers. Are A and B numbers? Nope, maybe, right? Exactly. As they are right now, are they? No. In fact, what you'll get out of this, you'll get something out of this. When you dereference a generic void pointer, don't quote me on this, but I believe that it treats it as a single byte. In other words, a character, right? And it will try to treat now A actually is an integer and it has 4 bytes. So all it's doing is taking that first byte and that first byte of B and A and B and it's comparing those. Are you going to get any meaningful results out of that? No. Ignoring 75% of the data? No. What was the first step here? I need to cast those 2 generic void pointers as integer types that I expect. Right? I'm expecting an integer here. So I need integers. Const int star x and const int star b, or bx. Why? Why? Because I've already used a and b, right? So I'm going to use x and y. And I cast a and b, const int star a and const int star b. Right? Now, x and y are a and b, pointers, but guess what? They are indeed now integers. They're numbers that I can deal with. Right? So now I don't look at a and b. Instead, what do I look at? X and y. If dereference of x, dereference of y is less than dereference of y, then what does that mean? That means that I've got a situation like this, 10 and 20. Right? So I return something negative, right? Because they're in order according to my ascending order desire here to have ascending numbers. All right. All right. Else if, well, just go ahead and go with the same pattern here. If that's greater than y, then return what? I could return anything positive. I could return 42 if I wanted to. Don't get fancy. Right? Just return negative 1, 1 is good enough. Right? Else, what's the only other possibility here? They're equal, so I don't even have to check. Right? And I return what? 0. There we go. That's my comparator here. Okay. Now let's go ahead and get rid of all of these. There we go. And let's try to build our own generic search algorithm here, or search function. Okay. All right, search. I'm not going to search integers anymore. What am I going to search? I'm going to search things, right? Search array, all right? Again, all I'm doing here is avoiding using search because there's already a search function in there. Actually, no, it's L search and B search, I think. But just to be safe, okay? All right. Is that going to work? Nope. You are searching what? Not integers, not doubles, but things. Void. I still need to know how many things there are because it's still an array, right? Here, that's not a key anymore. Oh, that's not an integer anymore. What is it? Const void star. Right? To keep it generic. Generic. Right? All right. I actually need something else here, but we'll come back to it. Right? So for int I equals 0, I is less than n. Now how do I compare them? Well, I need a comparator function, CMP, right? And if that's equal to 0, then I found what I'm looking for. Right? What do I pass into my comparator function? The ith element and the key. Okay. Now the key is already a void star function, or a void star thing here, right? That's what this comparator is expecting. But what about this thing right here, array sub I? Is that a comparator? Nope. So what is it? Or sorry, it's not a comparator. Is it a regular old? Is it a pointer or is it a regular old variable? It's a regular old variable. We expect a pointer. So what's going to happen? Or what do we need to make that into a pointer? Ampersand. There we go. We're still not. We're 50% there. We still need a lot. All right. Otherwise, it's a failed search. Okay. So let's go down here and try to clean it up a little bit. All right. So index of search array. All right. And I'm not going to be able to pass that in as a regular old key. Index of, here, key. There we go. All right. If you have a question, you can ask online if you want. Go ahead. GCC. All right. So there we go. All right. Well, first of all, CMP. Right. Did I actually pass that into a function? Nope. So how do I get my comparator, which in this case is called compareInt, into this function here? Right. So we need a new concept. Right. This new concept is going to be called a function pointer. Right. Now we're not going to cover it in its entirety today. Instead, I'll save that for tomorrow or something. But think about it this way. What's in memory? Everything. Data is in memory. So I can have an integer in memory, right? I can just have a regular old int, just like n here, and it's somewhere in memory. How do I get that something in memory? Ampersand n. That gives me the memory address of that particular variable. Well, what else is stored in memory? Everything, including my program. Main is stored somewhere in memory, right? So if you wanted the memory address of the function that I'm in right now, main with an ampersand in front of it. In fact, main is kind of like or functions are like arrays. When I pass this in, do I have to put an ampersand in front of it? In fact, that would be wrong. Why? Because the name of an array is already its pointer. The name of a function is already its pointer. Okay? How do we take that over here, though? We need some new syntax. So int cmp. I got to double check this. Don't quote me yet. Yep, there we go. All right, so int like this, and then a star here, right? So what is that? That's a function pointer. It is a memory address of where you can find this function in memory, right? And what does it return? Well, it takes const void star a. Did I call him a? Yeah, and const void star b. There we go. So, new syntax here, and it can be quite confusing. We will completely cover that on Wednesday, right? But for now, I'll just leave it. Let's come down here and actually pass those in. Right? So I want a comparator for integers. There we go. When I call and search for integers, I better pass in a comparator for integers. Now, before I do it down here, you guess what's going to happen here? If I am searching an array of doubles with a key of double, can I use a comparator for integers? What do you think is going to happen? So here are your two doubles. How many bytes are in a double? 8 and 8. But what's going to happen when we get into this function right here? It's going to treat them as integers. These 8 bytes, it's only going to pay attention to 4 of them. These 8 bytes, it's only going to pay attention to 4 of them. Are you going to get the results that you want? Not at all, right? You're going to get weird results, okay? You may or may not, likely you won't have any successful searches at all, even if you search for something that's in there, okay? Actually, I take that back. That would probably work, actually, right? Instead, what do we need? A comparator for doubles, right? Now, what's the only difference? Well, 2 doubles instead. Double, 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 double. Now, lots of repeated code, yes, but unfortunately in this case it is necessary repeated code because it's a completely different type. Okay? So let me go ahead and put this down here, and hopefully at this point it will compile. It may not run yet though. All right. Too few are. Oops. Did I screw up? Oh, sorry. Thank you. There we go. All right. Good. All right. So, like I said, we're about 75% there now. It's still complaining about this thing here because you are dereferencing not a null pointer, but you are dereferencing a void pointer. Okay? So let's think about this search array right here in those two situations that we've already covered, integers and doubles. Right? How do arrays actually work? Okay? So if this were an integer array, int, I don't know. Let's do it. Let's just take this array right here. Right? Think about how memory works here. ARR is a memory address of the start of the array. Right? ARR sub I is the second. Let's go with ARR sub 0 is the same memory address as ARR. Why? Because 0 is an offset. What it's saying is, here's the memory address. Where's the first element? Right there. Right? So ARR sub I is giving you that first element. 0 is giving you that first element. ARR sub 2 is the second element, or is the memory address, or is a reference to the second element. All right? How did it know where it was? So here's the first element, here's the second element. Suppose that this is at memory address 001. Right? I'll just do it like this. Right? There we go. How does it know where to find the second one? Well, this is an integer, right? The compiler knows how many bytes an integer takes. How many bytes does an integer take typically? 4. So where is the memory address of the second one? 0, well, 1 plus 4 is 5. AR sub 2 is a reference to the third element, which is at memory address, well, 4 more bytes over, where is it? 009, etc., etc. How does the compiler know all this? Because it's built into the language for integers. Up here in search, how do we know that? Sometimes it's 4 bytes, sometimes it's 8 bytes, right? For example, down here, BR, right? BR sub 1 is, if BR sub 0, oops, sorry, is at memory address 001, right? Then where is BR sub 1? Now be careful, it's 8 bytes now, so it's the offset is what? 9, right? BR sub 2 is going to be where? Be careful, 9 plus 4, and this is hexadecimal. So you go 9, A, B, C, D, E, F, G, A, not H. Then we wrap around, so now it's 1. And then what did I leave off? Darn it. 9 plus 8 is going to be 17, so we're just 1 now. There we go. All right. So do you see how that counting works, right? You count just like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but when you run out of fingers, right, then you start counting A, B, C, D, E, F, and then once you run out of letters, now you go back to 0, right? So don't worry about that, right? We're not doing that kind of arithmetic, but we are in need of what's called pointer arithmetic. How do I know the memory address of this thing right here? Right? Oh, sorry, that's me. Right. We've never enforced it, but one of my colleagues, when we team teach in another course, over there they've got this kind of arcane rule of if your cell phone goes off in class, during class, then you have to bring donuts next time. It's never been enforced, but it's like, come on, it's 2023, man. That's a old rule. But anyway, so my goal here is, what is the memory address of the ith element? Because that's actually what I need to pass in here, right? Question mark, question mark. I need to pass in the memory address of the first element, the second element, the third element, the fourth element, etc. So I need to do the math myself now, because the compiler does not know that these are integers or doubles or books or whatever, right? So how would I do it? Let's just think about integers first. Array is the start of the array. Right? If you want the ith element, right, then you want ARR plus I. But each element doesn't take just 1 byte. However many bytes each element takes. Right? Do you see that? Right? Because that's exactly the math that we just did down here that I erased. Right? It's ARR plus a byte offset. When you look at the first element, what is that? Well, then that term disappears, and what do you have? ARR. When you look at the first element and it's 4 bytes away, then it's ARR plus 4. Right? When you look at the third element and it's two elements away, but each one takes 4, that's going to be 2 times 4. That's 8 bytes away. Okay. So there's the general formula. The missing piece is this guy right here. Right? How do we get that? Size of, normally, right? Size of int or size of double. Which one do we have in this case, though? We don't. So we have to be told. Right? There are n elements in there, and by the way, they each take a certain number of bytes. Num bytes each. Okay? Now, strictly speaking, this is not exactly how you do it, but that's how I'm going to demonstrate it. Right? There we go. There's the memory address. Right? Let's take that and move it down here. It's called pointer arithmetic. We've got a pointer, and then we're doing plus, minus, multiplication, right? We're just doing arithmetic. Right? Now I'm passing in a generic void pointer here without actually dereferencing it. Right? That warning goes away. Right? Oh, sorry. Oh yeah, that's because I haven't changed anything down below. But everything else is fine now, once I change that. Oops. Come on. Clear. There we go. All right, so the number of elements in there, but then the number of bytes of each. So do we know how to do that? You just said it. These are integers, so it's going to be size of int. These are doubles, so it's going to be size of double. And now you can kind of see the parallel with malloc, right? Malloc needs to know, doesn't need to know what you are allocating. It doesn't need to know that it's integers or doubles or books. It just needs to know the size of them. Here you go. Here are your bytes. We don't need to know, or the search array doesn't need to know that, right? It just needs to know, here are the number of bytes that it takes. Everything is fixed now, and it runs perfectly, right? 8.5 is indeed at index 6. But guess what? Do I have copy, paste, copy, paste, copy, paste everywhere? I've got one function to rule them all, right? In fact, I shouldn't have even written that function. I don't have a man pages here. I'll search. See? I'll search. There we go. Isn't it? Darn it. What is it? I'm pretty sure it's L search. Yeah, there it is. All right, that's ugly, but whatever. There we go. This is almost exactly the same pattern that we just had. What is your key? It's a generic pointer. Your base is the array. They call it the base, though. NELP is the number of elements, right? And width is how many bytes it takes in memory. They just call it a width because how big is it, right? What's its width in bytes? And guess what this is? A generic comparator pointer, right? So we just reproduced this function that's built into the standard search library up here. Right? But we know how it works now. And knowing how it works, okay, now we don't have to write our own, right? All we have to do is what? Make a new comparator. What would it look like for books, by the way? I don't have any books here, but let's just write a comparator for it. Compare books. How are you going to compare it? There are lots of options here. Title, author's last name, first name. Right. What else? The year that it was published. The rating, right? And that's just the small piece of data that I put as the demonstration, right? By ISBN, by whatever, right? Publisher, by, you can think of 50 million different things that you could compare a book by, right? And all you'd have to do is write a new comparator for it. Let's do by title. Put it in the function name, right? Ascending, we'll get to that later. All right, so I don't change anything besides the name of the function because otherwise it would not be a comparator. What do I do down here though? I change it into a book. I change that into a book, book, book. Now, can I just compare them as numbers? No. So let's change this. How are you going to compare their titles? Exactly. Don't reinvent the wheel. strcmp, X's title and Y's title. Actually, I'm going to put that into a variable so I don't have to call it over and over again. Int X is equal to that. In fact, Do I even need to check to see what it is? Like if x is less than 0, what would I do? Return -1. Else if x is greater than 0, what would I return? 1. You see a pattern here? Else return 0. Should I even bother with that? What should I just do? Return x. You're done. All right? So we'll get into other little tricks like this later on. Yeah. Oh, R, fine. R for result. Yeah, you're right. It wouldn't have compiled. All right. Before we go, no, but I'll save the bad tricks for later, right? But otherwise, yeah, code reuse here. When we come back on Wednesday, I'll show you how to do the same stuff in Java, and then we'll come back and we'll study this function pointer a little bit more in depth. All right. All right. It's just spam online, it looks like.